So for problem 27, this is the figure. It shows the side view of a car tire. And it has two sidewalls of uniform thickness 0.635 centimeters, and a tread wall of uniform thickness 2.5 centimeters, and width 20 centimeters. Assume the rubber has uniform density equal to 1.1 times 10 to the third kilograms times meters cubed. And you're supposed to find the moment of inertia about this axis. So to start, I recopied this lovely diagram. So you can see this is the inner wall with 0.165 meters. This is from the center to the inside of the tread wall, which is 0.305 meters. And this is from the middle to the outside of the tread wall, which is 0.33 meters. So basically, I decided to treat this as multiple discs because, first of all, I wanted to figure out the sidewall. And we know that the density of the rubber is 1.1 times 10 to the third kilograms per meter squared. And so if you think about it, the moment of inertia of a cylinder with a little hole cut in the middle is going to be 1/2 m r1 squared plus r2 squared. Because initially you might think, oh, well, you should be subtracting them. But then if you think about it, the moment of inertia of a ring or something that has all of its weight on the outside is going to be more than something that has more weight on the inside. So the moment of inertia of something that has a hole cut out in the middle is going to be more than something that doesn't have a hole cut out in the middle. So this is the formula we're going to be using. But the first thing we need to find the mass. So in order to find the sidewall mass, we know we know the area of a circle, right? So we know if we're going to try and find the area of this little like ring part, we have to subtract the small area from the big area. So the area of the entire whole width, because remember the sidewall is from 0.305 to 0.165, so it's like this. So pi big radius squared minus pi little radius squared. So we get the area is 0.2067 meters squared. So then the mass is going to be the area times, it tells you that the walls have uniform thickness 0.635 centimeters. So that's going to be 0.00635 meters, because we want to find the volume of this little area and then multiply the volume by the density to get the mass. So 0.2067 meters squared times the thickness, and then you multiply that by the density, and you get the mass of the sidewall is going to be 1.44 kilograms. So going back up to this equation over here, to find the moment of inertia, it's 1/2 m r1 squared plus r2 squared. So 1/2 times the mass, r1 squared plus r2 squared, which is going to be in here. And then we're going to multiply by 2 because there's two sidewalls. Because if you think about it, there's the one on this side and then there's the one on the back. So in order to get the total sidewall moment of inertia is 0.1732 kilograms times meters squared. Okay, now we have to move on to the tread wall. The tread wall is going to be the thing on the outside, your tire tread. So in order to do this again, we're also going to do pi r squared minus pi r squared. But it's going to be a lot smaller because it's only 0.33 meters squared minus pi times 0.305 meters squared. Because we're basically finding this difference. You can't really tell in my diagram, but it's like from there to there. So the area of that is 0.0499 meters squared. And we're going to do the same thing we did up here to calculate the mass. We're going to have the area, and then it gives you that it's uniform thickness, or uniform width, 20 centimeters. So 20 centimeters is 0.2 meters. So we multiply the area times the width to get the volume, and then you multiply that by the density, and you get the mass is 10.97 kilograms. Then again, we go back to our moment of inertia equation, 1/2 m r1 squared plus r2 squared, 1/2 mass, and then the bigger radius all the way to the outside minus the smaller radius, which is just to the inside. And you get the tread wall MOI is 1.108 kilograms times meters squared. Now all you have to do is you have to add the sidewall MOI to the tread wall MOI to get the total, which is going to be 1.28 kilograms times meters squared. It's a lot of equations, but basically all I have to do is plug it in.